Okay, so now we're going to look at synthetic division. Synthetic division is really just a way to quickly do division of polynomials if your polynomials of the form x minus c. What does that mean, x minus c? Like x minus 3 or x minus 4 or x minus 1/2, x minus something, okay? So that's your divisor. That's below, right? That's the guy below. If your divisor is of the form x minus c, then this process is a lot faster. You can go a lot quicker to find the quotient, okay? So I'm going to go through this process. I want you to kind of pay attention to the details of what I do. Remember, it has to be of the form x minus c. Is this guy of the form x minus c? Well, not really. It's x plus 3, right? Where 3 is what you might think to be c. Well, it's actually not, because we want x minus. To get x minus, it'd be x minus a negative 3. So you have to see that form first. You have to identify that it has to be in this form, okay? So really what we're looking for is x cubed minus 8x plus 2 divided by x minus a negative 3. Now that's of course equal to x plus 3. But we know now c is negative 3. So this is the process for synthetic division. Well, you take this guy, the c value. You put it right here. You put a box around it. Help you remember what it is, okay? So far so good. And then what you do is you take each of the coefficients of your numerator of each term in the numerator in descending order. So right here we have a numerator here. It's a degree 3 polynomial, okay, degree 3. What's the degree 3 coefficient? What's that number in front of the x cubed? Well, it's a 1. Now, the next degree down is degree 2. We don't have a degree 2 term here, so that would be 0. It would be a 0 for a degree 2 term coefficient. Now my degree 1 term has coefficient negative 8. And then finally my degree 0 term has coefficient 2. Okay? That's the first thing that we do. Now the next thing that we do is we draw a line here, giving us some space in between this row of coefficients and this. Now what I do is this. Okay? I take the first number, whatever this first number is, and I always drop it down. Okay? I always drop it down. And then what I do is I multiply negative 3 times 1, okay, negative 3 times 1, and I put it here, okay, I put that negative 3 times 1, I put it there, negative 3 times 1, put it here, and then what I do is I add down, this plus this gives me negative 3, and then I multiply this guy times this guy, negative 3 times negative 3 is positive 9, and I put that positive 9 here, and then I add down, and if I add down, 9 and negative 8 make 1. And then I multiply negative 3 times 1 here. I put the answer to that right here, negative 3. And I add down, and it gives me negative 1 on color. Okay? And the way this works is the following. Once you finish this guy is always your remainder. Then I have here degree 1 term, degree 0 term, degree 1 term, degree 2 term. It goes 0, 1, 2, and there's more than 3, 4, 5, and so forth. So, my remainder is negative 1. So, negative 1 is my remainder divided by, what was my divisor? X plus 3. My degree 0 term will be 1. That's my constant. My degree 1 term will be negative 3. My degree 1 term is negative 3x. And my degree 2 term has a coefficient of 1, so I'll have 1x squared. So my answer is x squared minus 3x plus 1 plus the negative 1 over x plus 3. So it's a lot faster than doing long division. Suppose I had tried this problem by long division. Okay, let's do long division. X cubed plus placeholder 0x squared minus 8x plus 2. What do I want to multiply to at least get x cubed? Well, you want to multiply by x squared. So x squared times this is x cubed, and I'll get 3x squared here, positive. Distribute the minus sign, that becomes plus, negative, negative. And if I subtract negative 3x squared minus 8x, okay, good. Multiply it by negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times negative 3, or positive 3 is negative 9x. Okay, subtract downwards. What do you have to do? Make sure you distribute the minus sign. Plus, 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 add down. I get x, drop down to 2, x plus 2. What do I want to multiply by to at least get x? Multiply by root 1, so plus 1. And I'll get x plus 3. What do I do downwards? I subtract. X minus x is 0. 2 minus 3, again distribute, plus negative negative 2 plus negative 3 is negative 1. And I get precisely what I got here, but a much slower process. So synthetic division has a lot of value because it's a lot faster when you have something of the form x minus c. So if it's plus, you gotta make it minus. Okay, and use that as your number in your box, right? Okay, so now we're going to talk about the remainder theorem. This is a really cool theorem. If the polynomial p of x is divided by x minus c, so in other words, a linear factor, right? Linear in the sense that it's not a square or a cube or anything else. It's x minus c, okay? Then the remainder is simply p of c. What the heck does that mean, p of c? Well, c is a number, right? We're subtracting a number. What number we're subtracting? If you plug that into your original function, you get the remainder. So I'm going to do this problem here two ways. One using synthetic division, which is actually not that bad, and the other one using this theorem, okay? So I think you'll find that the theorem is actually much easier. So let's, first off, we have x plus a number, so we want x minus a number, so we know that our c is negative 2, right? So we always want x minus what? X minus negative 2. Then we put the coefficients down, 3, 5, negative 4. Why 0? Because there's no degree 2 term, 7, and then 3. Draw a line. Okay. Drop this one down. 3, negative 2 times 3 is negative 6. Add down to be negative 1. Negative 2 times negative 1 is positive 2. Add down to be negative 2. Negative 2 times negative 2 is 4. 4. Add down gives me 4. 4 times negative 2 is negative 8. Negative 8. Add down gives me negative 1. Negative 2 times negative 1 is 3. Add down, oops, wrong color. Add down gives me 6. Okay? Now, that wasn't that bad. What this theorem does is it makes it a lot simpler. Notice that this is a polynomial p of x, and we're dividing it by x minus c, where c is negative 2. So if I take this polynomial, p of x equals this, and instead of putting in x, I put in c, and look at p of, note that p of x equals 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. Well, if I look at p of c, in this case, what is our c value? Our c is negative 2. So if I look at p of negative 2, I'll get 3 times negative 2 to the 5th plus 5 times negative 2 to the 4th minus 4 times negative 2 to the 3rd plus 7 times negative 2 plus 3. So I get 32. 32 times 3 is 96. 16 times 5, I get 80. Okay. And then I get negative 8 times 4, negative 4, is positive 32. Okay. And then I get, the other way, this is negative 96. And then I get here negative 14 plus 3. And if I add all this together, negative 96 and 80 is negative 16, plus 32 is positive 16. 16 minus 14 is 2. 2 plus 3 is 5. Right? Did I make a mistake here? Oh, here it is. Negative 2 times negative 1 is positive 2. Here it is. That's why. So that's 5. Arithmetic. Always arithmetic. So notice that these two numbers, there you go. Make sure you watch the whole video to recognize that mistake. Those two numbers are the same. Which way is a little bit easier? This is simply arithmetic right here. And for larger polynomials, this way is much easier. All you have to do is plug that number in to find the remainder. My question was find the remainder. Here's my remainder. That's the same number as this. This way it was a lot easier to understand. Okay? So this is the remainder theorem. If we're dividing by a linear factor, all you got to do is plug in that number to find out what the remainder is. Okay? All right, last little theorem, but it's a big one in the sense that it has a lot of applications. It's called the factor theorem. If c is a 0, that means if you plug in c to your polynomial, you get 0, right? Like, for example, if you have p of x equals x minus 2, then 2 is a 0. X equals 2 is 0. So c being 2 is 0. Because if you plug it in, you get 0, right? Okay, c is a 0 if and only if x minus c is a factor of p of x. Now that should make sense, because we just looked at the remainder theorem. Now if we plug in c, okay, and we get 0 remainder, that means it went in perfectly, right? It divided in perfectly. And if it divides in perfectly, then that means x minus c should be a factor of it, okay? So let's understand that here. For example, p of x equals x cubed minus 7x plus 6, okay? If we tried to factor that with our current methods, we couldn't. This is not a degree 2 term, or degree 2 polynomial, okay? Degree 2 polynomial, tic-tac-toe, crisscross applesauce, the whole deal. You can use all kinds of methods to factor that. But this is a degree 3 polynomial, right, where we're missing a degree 2 term. The factoring choices that we have here are limited. But check this out. If I plug in 1, note what happens. P of 1 equals 1 cubed minus 7 times 1 plus 6. 1 minus 7 is negative 6 plus 6 equals 0. Which means 1 is a 0, right? I plug in 1, it gave me a 0. Therefore, x minus 1 is a factor of this polynomial. That means I will divide, if I divide x minus 1 into this polynomial, I will get remainder 0, so I can rewrite this as an expression of x minus 1 times something else. Take a look. Using synthetic division, x minus c, therefore c is 1. I put 1, 0 from the degree 2 term, negative 7 and 6. Draw a line, drop this down. 1 times 1 is 1. Okay, add down, get 1. 1 times 1 is 1. Add down, get negative 6. 1 times negative 6 is negative 6. Add down, get 0. So recall, this is my remainder. This is my constant term, or degree 0 term. This is my degree 1 term. Okay, and this is my degree 2 term. So I can rewrite this as, if I divide x cubed minus 7x plus 6 and divide it by x minus 1, I get this. So that is to say, divided by x minus 1, I got x squared, degree 2 term x squared, plus x minus 6, no remainder. Now, what does this say? Multiply both sides by x minus 1. That says x cubed minus 7x plus 6 equals x minus 1 times x squared plus x minus 6. Okay? So now I've just factored this, haven't I? I've just factored that. And can I continue to factor this little polynomial using old tic-tac-toe methods? Absolutely. So now I have these different colors, red one now. This equals x minus 1 times x plus 3. Again, this is right here, times x minus 2. I just factored a degree 3 polynomial, right? Noting that I know the factor theorem, I was given that one of the zeros is 1. Plug that in, was able to factor this completely. That's pretty cool. We don't know how to factor things like this, but if we're given something that shows p of 1 equals 0, so in other words, we know x minus 1 is a factor, I can use long division or synthetic division to extract that out, see what's left, and then factor that guy.